Chillers may look complicated, but choosing the right type becomes easy once you understand how each compressor works. Meet the four major how do they work, where are they used, and which one fits your project. Let's break them down, one chiller at a time. Welcome! In this lesson, we're exploring the centrifugal chiller. It is one of the most powerful and efficient chillers used in large HVAC systems. This type of chiller is typically used for medium to very large cooling loads. This makes it ideal for towers, hospitals, malls, airports, and major facilities. One big advantage is its wide capacity range. Centrifugal chillers commonly start around 150 TRs and can reach 6,000 or even more, depending on the manufacturer. A centrifugal chiller usually uses a high-speed compressor with one main compression train. One or more impellers accelerate the refrigerant to create the required pressure rise. Its capacity is commonly controlled by inlet guide vanes, variable speed control, or both. That is why centrifugal chillers can achieve excellent efficiency, with COP values off. So, if you need high efficiency, reliable performance, and large cooling capacity, the centrifugal chiller is a top solution. Let's continue and discover more chillers together. In this lesson, we'll explore reciprocating chillers, one of the oldest and most important chiller technologies in HVAC. A reciprocating chiller can be either air-cooled or water-cooled, and it is considered an older positive displacement refrigeration technology. This type is mainly used for small to medium cooling loads, where the system size and operating conditions fit its practical range. Typically, reciprocating chillers are available in capacities from about 50 to 500 TR, depending on the manufacturer and system configuration.
The heart of this chiller is the reciprocating compressor, which uses pistons moving inside cylinders to compress the refrigerant. As the piston moves down, refrigerant vapor enters the cylinder. As it moves up, the vapor is compressed and discharged at a higher pressure. Capacity control is commonly achieved by compressor staging or cylinder unloading, which helps the chiller match the building load more efficiently. In some designs, speed control may also be used, but staging and unloading are the more common control methods for reciprocating systems. The COP typically ranges around 4.2 to 5.5 under suitable conditions, but the actual value depends on operating temperatures and equipment design. Air-cooled reciprocating chillers are simpler to install, while water-cooled versions usually offer better performance in larger and more stable applications. Although this is an old technology, it remains a great learning example because it clearly shows the basic principle of refrigerant compression. Reciprocating chillers are reliable, easy to understand, and ideal for learning the fundamentals of chiller operation. Let's continue to the next type.
We're exploring the scroll chiller, a compact, efficient cooling solution widely used in small to medium HVAC applications. Scroll chillers can be either air-cooled or water-cooled, and they are typically selected for small to medium cooling loads where simplicity, reliability, and efficiency are important. A typical capacity range for scroll chillers is about 40 to 400 tons of refrigeration, making them ideal for commercial buildings, villas, schools, and light industrial facilities. The heart of this system is the scroll compressor. It uses two interleaved scrolls, one fixed and one orbiting, to compress the refrigerant smoothly, efficiently, and with low vibration. Capacity control may be achieved by compressor staging, solenoid-based unloading, and electronic modulation, depending on the manufacturer's design and the required part load performance. The air-cooled version is easier to install and does not require a cooling tower. Typical COP values may range around 3.2 to 4.86, depending on operating conditions and equipment quality. The water-cooled version usually offers higher efficiency and smoother operation. Its COP can typically range from about 4.45 to 6.2, especially when water temperatures are well controlled. So, if you need a reliable chiller for small to medium loads with compact design, quiet operation, and strong efficiency, the scroll chiller is a smart and practical choice. In this lesson, we're talking about the screw chiller, one of the most reliable and efficient chillers used in many HVAC systems today. In chillers are known for high efficiency, stable performance, and strong reliability. They also handle part load operation well, which is very important in real HVAC systems. In general, water-cooled screw chillers offer efficiency than air-cooled ones. Typical C values may range from about 2.9 to 4.15 for air-cooled units. One major advantage of the screw chiller is flexible capacity control. This is typically achieved by slide valve control, variable speed drive, or a combination of both. In many water-cooled screw chillers, you may find one main screw compressor. In air-cooled units, one or two compressors are common, depending on the required capacity and strategy. The heart of this chiller is the screw compressor. It uses two meshing helical rotors, a male rotor and a female rotor, to compress the refrigerant continuously and smoothly. Screw chillers are commonly used in small to medium, often medium to large applications depending on the model. A practical range is around 70 to 600 tons of refrigeration. A screw chiller can be either air-cooled or water-cooled. Both versions do the same job, removing heat from the building and delivering chilled water to the system.